itself. The journey ahead is filled with promise and potential, and it all begins with the language we choose to speak. The universe speaks in many languages. Each star, each planet, each particle of matter has its own way of communicating its existence and its story. From the whisper of the cosmic microwave background, the faint echoes of the universe's birth, to the roar of a supernova, a cataclysmic event that reshapes the cosmos, each phenomenon has its own unique voice, a signature that tells us more about the universe we inhabit. In our quest to understand the cosmos, we too have developed languages. These languages, whether mathematical equations or computer code, allow us to decode the mysteries of the universe. These languages allow us to communicate complex ideas and build incredible technologies. They are the bridges between human thought and machine execution. Today, we stand on the precipice of a new age of intelligence, one powered by artificial minds. These minds, created by us, have the potential to surpass our own in many ways. To unlock the full potential of AI, we need a new language, one that can handle the intricacies and demands of artificial intelligence. Enter the AI 231 model, a novel approach to natural language processing that integrates mathematical expressions alongside natural language. This unique fusion aims to establish a more expressive and precise communication method between humans and computers. Drawing inspiration from the human brain's intricate structure, the AI 231 model mimics how the brain processes and comprehends language. It leverages mathematical calculations from crystallography and sonography imaging systems to represent the configuration of letters. This approach aims to make the relationships between words and phrases not only informative, but also aesthetically pleasing. The AI 231 model incorporates two distinct graphical representations to simulate the interplay between crystallography, sonography, and mathematical processing. Imagine a language that can seamlessly integrate the raw computational power of CPUs, harnessing their ability to perform billions of calculations per second, the parallel processing prowess of GPUs, which can handle multiple tasks simultaneously with incredible efficiency, and the generative capabilities of GPT systems, which can create human-like text and even generate new ideas. This is the promise of the AI 231 model. It is a language that can bring together the best of all these worlds, creating a synergy that propels AI development to new heights. This new breed of language will allow us to express complex AI algorithms with elegance and efficiency. It will enable us to write code that is not only powerful but also beautiful in its simplicity. It will enable us to automate tasks that once seemed impossible, tasks that require a level of intelligence and adaptability that only AI can provide. Freeing human minds to explore the furthest reaches of knowledge and creativity, with AI taking care of the mundane and the complex, we can focus on what truly matters: innovation and discovery. Join me now as we delve into the exciting world of the AI 231 model. Together, we will explore how this approach is poised to revolutionize the future of intelligence itself, and explore how it is poised to revolutionize the future of intelligence itself. The journey ahead is filled with promise and potential, and it all begins with the language we choose to speak. The universe speaks in many languages. Each star, each planet, each particle of matter has its own way of communicating its existence and its story. From the whisper of the cosmic microwave background, the faint echoes of the universe's birth, to the roar of a supernova, a cataclysmic event that reshapes the cosmos. At its core, an AI model designed to write code characters must be built on the principles of crystallography. This means it should leverage crystal structures, stenographic illustrations, and text forms to create a robust and efficient programming language. Just as crystal structures can exist in multiple forms, the AI model should allow for a fluid and dynamic representation of information. This fluidity is essential for creating systems that can adapt and evolve in real time, responding to new data and changing circumstances with ease. The AI model should handle multiple calculations simultaneously, allowing it to perform complex operations efficiently. This means that instead of being constrained by classical binary logic, programmers can explore new ways to solve problems and develop innovative solutions. Traditional AI models often rely on rigid structures and linear execution paths. These architectures are designed for precision and control, but they can be limiting when it comes to developing systems that need to think and learn like humans. While effective for many tasks, these limitations can hinder the development of truly intelligent systems. The rigidity of traditional architectures can make it difficult to implement the kind of flexible, adaptive behavior that is characteristic of human intelligence. Our AI model will embrace a more organic approach. By mimicking the way crystal structures interact and process information, we can create systems that are more intuitive and capable of complex reasoning. Instead of forcing programmers to think in terms of classical logic gates, it will allow them to express ideas as crystallographic operations. This shift in perspective can lead to more innovative and effective solutions, as it encourages a more holistic and integrated approach to problem solving. This will be achieved through a multi-layered semantic analysis framework, where each layer represents a specific operation, data point, or concept. This visual and conceptual approach makes it easier to understand and manipulate complex systems, as it mirrors the way we naturally organize and process information. Connections between layers will define the flow of information and the relationships between different elements. This interconnected structure allows for more flexible and dynamic interactions, enabling the system to adapt and respond to new information in real time. This multi-layered structure will mirror the interconnected nature of neurons in the human brain. By emulating the brain's architecture, we can create systems that are capable of more sophisticated and nuanced processing. Just as our thoughts emerge from the complex interplay of billions of neurons, our AI model will allow systems to process information in a similarly distributed and interconnected manner. This distributed processing is key to achieving the kind of flexibility and adaptability that is essential for true intelligence. This approach will be crucial for developing AI that can reason, learn, and adapt to new situations. By allowing the system to evolve and grow, we can create AI that is not only more intelligent, but also more capable of understanding and interacting with the world in a meaningful way. The syntax of the language will be designed for clarity and conciseness. This means that even complex crystallographic operations can be expressed in a way that is easy to understand and work with, reducing the cognitive load on the programmer. Verbose commands and complex symbol combinations will be replaced with intuitive keywords and symbols that reflect the underlying crystallographic concepts. This makes the language more accessible and easier to learn, even for those who are new to this form of programming. This will make the language easier to learn and use, even for those without a background in crystallography. By lowering the barrier to entry, we can empower a wider range of people to contribute to the development of AI. The goal is to create an AI model that is both powerful and accessible, empowering a new generation of developers to push the boundaries of what's possible. By combining the best of crystallography and semantic processing, we can unlock new possibilities and create a brighter future for all. Pause 3S. The internet has revolutionized the way we communicate, learn, and work. However, it is still largely based on a static model of content and applications. This new model proposes a new way of thinking about the internet, where the net itself, the text itself, and the program itself are used as software. Pause 1S. This would create a more intelligent, responsive, and secure internet that is more accessible to everyone. The internet could become more intelligent and responsive to our needs, much like how different regions of the human brain specialize in various functions. Pause 1S. It could learn our preferences and recommend content and applications that are relevant to us. This would make it easier to create and share new types of applications and content, leveraging the power of the net itself to build applications. Pause 1S. The internet could become more secure and reliable, implementing security features and detecting attacks. This would also make it more accessible to people with disabilities, developing content and applications in a way that meets different needs. By linking the architecture to a neural network, we ensure that our AI model can learn and evolve in response to new data and changing conditions. Pause 1S. Through this structural planning and neural integration, we create a robust and adaptable foundation for our AI model, paving the way for more intelligent and autonomous systems capable of identifying contradictions in international linguistic logic law. This integration highlights the connection between neurons and the architecture of the whole system, forming a new universal programming language. The multidimensional relationship of the Internet's architecture and quantum computing language creates a new esoteric programming language for AI. This new language integrates the midpoints of the Internet connection, automating a universal programming language for AI on the network.
One of the most powerful features of the AI 231 model is its ability to combine mathematical expressions with natural language to enable more expressive and precise communication with computers. The AI-231 model uses crystallographic charts to understand the relationship between the shape of a letter and its corresponding mathematical expression. Imagine a system that can generate mathematical expressions from natural language text. When the model identifies a specific pattern in the data, it can automatically trigger a series of actions. These actions might include generating new code, alerting a human operator, or even switching to a different algorithm altogether. The AI-231 model acts as an intelligent agent, constantly monitoring the state of the system and taking actions to ensure optimal performance. This will be crucial for developing AI systems that can operate autonomously and adapt to changing conditions without constant human intervention. Moreover, the AI-231 model facilitates the creation of self-learning AI systems. By analyzing the data flowing through the system, AI-231 can identify patterns and correlations that can be used to improve its own performance over time. This ability to learn and adapt will be essential for developing AI that can truly revolutionize the way we interact with computers. In the context of PP-GPT AI and world governance operations, the concept of superpositionality can be creatively applied to algorithmic construction. Superpositionality can metaphorically represent how decisions or actions exist in multiple potential outcomes until data is processed and a final state is observed or implemented. This framework could be used in PP-GPT AI models for decision-making and governance by simulating various scenarios before choosing the optimal one based on inputs like efficiency, transparency, and accountability. By applying quantum-inspired parallel processing techniques, these systems can assess multiple possibilities simultaneously, processing vast amounts of data from municipalities, autonomies, and governing bodies. This allows for real-time decision-making that adapts to new data dynamically, ensuring flexible and responsive governance. AI systems could operate based on quantum-inspired networks where decisions and actions propagate through a web of interconnected teams in real time, adjusting strategies dynamically based on incoming data streams. The PP-GPT AI can automatically group municipalities, governing bodies, or teams based on shared characteristics and their potential to affect multiple governance outcomes simultaneously. By integrating the concept of superpositionality from quantum mechanics into AI-driven governance and PP-GPT operations, we can build highly adaptive, real-time systems for world governance. These systems use algorithmic constructions to dynamically assess and distribute responsibilities, predict outcomes, and provide global solutions that account for the complex, interconnected realities of modern governance. The AI-driven architecture will thus optimize decision-making and distribute messages to relevant teams based on observed data and potential outcomes, ensuring a flexible and responsive governance system.